So if I put the value m is equal to 1 by 3 into this equation, so let's see, 3, this equation, 3 into, that will be 1 by 27, 3 cube is 27, plus 5 over 9 plus 10 over 3 minus 4 is equal to, so this is 1 over 9, this is 5 over 9, this is 10 over 3, we can make it as 30 over 9, and then it will be multiplied by 9 minus 36 over 9. Okay, so now what is this? 9, 1 plus 5 plus 30 minus 6, that is 0 over 9, it's 0. So this is the root. M is equal to 1 by 3 is the root. So if m is equal to 1 by 3 is the root, so that means 3m minus 1 is the factor of this equation. If 3m minus 1 is the factor, then what is the other factor that we can find from long division? Okay, so we can perform the long division here. 3m minus 1 times 3m cube plus 5m square plus 10m minus 4. So we multiply by m square, so it will be 3m cube plus minus m square. So subtract it, 6m square plus 10m. Next we multiply by 2m. So 2m into 3m is 6m square minus 2m. So it will be 12m minus 4, and then we multiply by 4, it will be 12m minus 4. So everything has been cancelled out. So we get these two factors, okay, 3m minus 1 and m square plus 2m plus 4 equal to 0. So one of the root we know that it is m is equal to 1 by 3. So the other two roots will come from this quadratic equation. So minus 2 plus minus 2 square minus 4ac. So it is divided by 2 into 1, okay, for this equation. So minus 2 plus minus 4 minus 16 is 4 minus 16 is 12 and square root. So 12 square root can be written as minus 12 square root can be written as like this over 2. It will be minus 2 plus minus, so 12 is 4 by 3, so it will 4 square root of 4 is 2. 2 square root 2 under root minus 3. Okay, so it will be 2. So it can be written as minus 1 plus minus 3i. Okay, it can be written as plus minus 3i because 2 divided by 2 is 1, 2 divided by 2 is 1, so this 3 it will be under root 3i. Right, this is value. So now we can write, we know the roots, So the solution will be c1 e power 1 by 3, that is x by 3, c2. So these are now the complex roots. So we can use some other constants a and b. So these are the complex roots. So it will be a is here -1. So it is e power minus x times a cosine under root 3x plus b sine under root 3x. So this is the solution. Let's consider another type of ordinary differential equation, which is Euler, which is called after the name Euler-Cauchy equation. Euler-Cauchy equation. It is an addition to the higher order ordinary differential equation with the non-constant coefficients. So we have just finished the solution of the homogeneous second order and higher order differential equations with the constant coefficients, but this is the one with the non-constant coefficients. So the characteristic of this equation is that, so for example, if you take like a second order equation, so this equation will be like that. It will be x square y double prime plus x y prime, or we can also say that a x y prime plus b y is equal to 0. So it will be this type of equation. Okay, so now we are considering the Euler-Cauchy equation. So this is a special type of equation which has some similar characteristics with the homogeneous higher order equation. So this is one example of the Euler-Cauchy equation for second degree. This equation is different from the homogeneous equation with constant coefficients in that sense that there are non-constant coefficients in terms of x square and x with y prime and y double prime. But the main thing over here is that the order of the differential matches with the power of x. So if this is the power of 2, then order is also 2. If here is power of 1, then the power of y is then the order of y is also 1. So the order of the differential matches with the power of x. So in this type of equation we can solve by using a substitution. Y is equal to x power m. So if y is equal to x power m, then y prime will be m x power minus m minus 1, and y double prime will be equal to m into m minus 1 into x power m minus 2. So now we substitute these values into this equation, then what we get is x square y prime is m minus 1 x m minus 2, and then plus a x is x, and then y prime is mx power m minus 1, mx power m minus 1, and then plus b, y is x power m. So equal to 0. In this case, what you can see is x square and then x power minus 2, they cancel out, so that becomes 1. And here we are left with m into m minus 1. and we also have this term x power m, and x power m is also a term over here, and x power m also a term here, so we can divide throughout by x power m, so x power m is also eliminated. So all the x terms are eliminated over here, only m term remains. Then for this next term, x is eliminated from here, x power 1, x power minus 1, and then what is left is am, and here only b is left. So we get this equation. Okay, this is an equation. This is a quadratic equation. We can convert, make it in a standard form: m square. This is minus m, and then this is plus a. So it will be a minus 1 m plus b equal to 0. So this is the standard, this is the characteristic equation. So if we are given any Cauchy equation, so we can find this characteristic equation, and then the roots of this characteristic equation will determine the solution of the equation. So let's see it with the help of one example. So the equation is x square y double prime plus 1.5 xy minus 0.5 y. So first of all, let's check whether this equation satisfies the conditions of Euler-Cauchy equation. So it seems that this equation satisfies the conditions, because second order, second power, first order, and first power of x. Okay, and the value of a is now 1.5, value of b is minus 0.5. So the characteristic equation according to this formulation will be m square plus a minus 1, a is 1.5 minus 1 is, then comes 0.5, and then the value of b will be minus 5, minus 0.5, so it will be minus 0.5 equal to 0. So this is a m. So this is the equation. So we can solve this equation by the quadratic formula. So it will be minus 0.5 plus minus 0.5 square minus 4 into 1 into minus 0.5. So divided by 2. Okay, when you will solve it, you will get values of minus 1 and 0.5. Okay, so we got two distinct roots in this case, but remember that now from this distinct root, the formula is not in the exponential form, the formula is in the power form, because the solution was in this form, y is equal to x power m. So the general solution will be then c1, if I take x1, y1 is this, so c1 x power minus 1 plus c2 x power 0.5. So in other words, c1 over x plus c2 square root of x. This is the general solution.